This is in your book. If you want to take a picture of this on the screen or from your book on page 118, this is the quadratic formula. You're familiar, you should be familiar with the quadratic formula. There's a couple things to keep in mind when we look at this. This is the standard or general form of a quadratic equation. Okay, ax squared plus bx plus c equals 0. A is the coefficient that always goes with the x squared term or the squared term. B is the coefficient that always goes with the x term, and C is always the constant. This formula you need to memorize if you don't have it already memorized. Okay, I will not be providing it for you. And we're going to go through two examples today, and I'm going to show you some strategies that I like to use that I highly recommend you also use to maximize the number of points you would ever get on a test or quiz, so I can see all that work and make sure that you're doing it correctly. In these examples that we're going to look at, okay, both examples are going to have some things that we have to do first to get them into standard form. In this case, what am I going to have to do first? Distribute the x. So when I distribute the x, I get x squared minus 8x equals 3. Now I just need to bring the 3 to the other side, and it'll be in standard form. Now here's the part that I'm not going to require that you do, but I highly recommend that you do, because there's lots of places in the quadratic formula where you can make a mistake, right? And of course we want to avoid that. So what I like to do is identify A, B, and C first and literally write it out so that we can remember what numbers we're supposed to be plugging in where. So in this problem, at this point, what is the value of A? 1. So that's the coefficient on the x squared term. What's the value of B? Negative 8. And the value of C? And so I like to write those down. And I think that, again, it kind of helps you find your way and make sure you're staying on the right track. At this point, I want you to go ahead and finish the problem. We are not looking for decimal answers. We are looking for simplified radical answers, okay? Exact answers. So go ahead and try to finish that one. Here's my setup, okay? Now here's what I also recommend. When you plug things into the quadratic formula, I highly recommend putting things in parentheses, except for really this front term, because this front term is always just the opposite sign of b, right? One of the reasons I recommend that is particularly for the b squared term. Oftentimes you guys will forget to put the parentheses, and when you type in your calculator minus 8 squared, it'll give you negative 64. Because it's not also squaring the negative, which it should. So I recommend putting things in parentheses. We simplify a little bit, and we should get down to this place. Okay? Yeah. How many got to that place? Okay, good. Now I need to find a factor of 76 that's a perfect square. Any ideas what a factor of 76 is that's a perfect square? 4? 4 times what gives me 76? 19. Okay, so I'll break that down. Is 4 times 19, and so the square root of 4, of course, is 2, so the 2 comes out, 19 stays in. And now I can reduce this because there is a factor of 2 that goes into all 3 of these numbers. It has to go into all of them. Okay, so 2 goes into 8 4 times, 2 goes into 2. So I get 4 plus or minus root 19, and that's the exact final answer. How many had that? Okay, not as many of you because you didn't keep going with the 76, I'm going to assume. Right? You've got to look for that. You've got to look for factors underneath the radical that can come out, because then I can simplify further. And we want our final answer to be simplified as much as possible. Another example. Now this example is not great, but you're going to see something like this in your homework. Okay? This is not in standard form. Standard form actually requires A, B, and C to be integers, and A has to be positive. So what we need to do with this problem first is get rid of the fractions. And I will just point this out. Even though we spent some time in the beginning of chapter 1 talking about how to clear fractions, many of you on your quiz chose not to do that. And that cost you some points because you ended up not doing it correctly. In this problem, you could actually plug in 5/12 for A and negative 1/2 for B and 1/4 for C, but that would be a nightmare. That that quadratic formula with a bunch of crazy fractions is a bad idea. I don't recommend doing that. What I do recommend is getting rid of the fractions. And our strategy that we learned last week about how to get rid of the fractions is what? What do we do here?
Multiply 2 by 6, 4 by 3, multiply everything by 12.
Okay, generally speaking, what are we going to do?
Denominator.
Which was the last thing you said.
Multiply them by a common denominator.
Multiply by the lowest common denominator. And in this case, the lowest common denominator is 12. This will clear the fractions. And then we'll have an equation that's a lot nicer. Okay, so the 12s are going to cancel here. The 12 and the 2 will cancel to give me a 6, and the 12 and the 4 will cancel to give me a 3. So I have a much neater, nicer equation that's technically in standard form. Okay, so what's A here? 5. What is B? And C. Okay, so I have those. Go ahead and finish it. I plug it in. Here's what I get. Okay, and then that reduces down to 6 plus or minus the square root of negative 24 over 10. So we are going to have some imaginary numbers here, and so I'm going to break negative 24 as negative 4 times 6, and the square root of negative 4, of course, is 2i. All right, so I get 6 plus or minus 2i root 6 all over 10. A 2 goes into 6, 10, and 2. So I can take a 2 out of all of those, use it. So I get 3 plus or minus I root 6 over 5. You could leave it like that. You could separate it into a plus bi form, separate it, period. Either one of those are acceptable. Okay, if you wanted to take this I and slide it over so it was technically a plus bi form, you could do that. But either one of those answers will work. Okay, how many had those? Okay, good job. All right, so that's quadratic formula. All right, you don't have too many problems. You should be able to knock it out.